7.0 Prerequisite Skills Quadratic Expressions. So let's just review some of these terms. A numerical coefficient is a number that multiplies the variable. Okay, so it is a number and like the variable is like the letter portion. Okay, so in example 1, we just have to identify the number part. So the numerical coefficient of each term. So for 3x, the numerical coefficient is 3. And b, negative 5x, the coefficient is negative 5. Okay, a polynomial can have one term, which we call a monomial, two terms, a binomial, three terms, a trinomial, or more than three terms, and we just call that the general polynomial. Okay, and just as a recall, terms are separated by a plus or a minus sign. So, example 2, identify each expression as monomial, binomial, trinomial, or polynomial. So one term, two terms, three terms, or four terms. Okay, so we have two terms here separated by a plus sign. So two terms, and that's a binomial. This one's just one term, right? We don't have another term separated by a plus or a minus sign. So this is a monomial. Okay, we got three terms here. So this is a trinomial. Trinomial. Okay, and then we have 1, 2, 3, 4. So four terms here. So we just call this the general polynomial. Okay, example 3, we're going to multiply or divide. So when we multiply 2 times negative 3p, we multiply normal numbers. Okay, so 2 times negative 3 is negative 6, and then the p is now just multiplied. So negative 6 times p essentially. Okay, b, negative 2 times negative 5q. So negative 2 times negative 5, those are both normal numbers, and they multiply to 10. And then we have a q, so we put the q on the side. And it's just like saying 10 times q. Okay. For c, we have 2x times 3x. The coefficients are 2 and 3. When we multiply those, we get 6. And then we have x to the 1 and x to the 1. And as a recall of exponent laws, if we have x to the 1 times x to the 1, what we're doing is we're actually adding these two exponents, so we get x squared. Okay, so D, E, and F are division questions. So negative 12x divided by 6. So essentially we're just dividing the numbers. Negative 12 divided by 6 is negative 2, and then the x is still multiplied there. It just comes down. Okay, for E, we have negative 25 y squared over negative 5y. So we're going to divide the numbers. Negative 25 divided by negative 5. We get 5. And then we're going to divide the variables. So we have y squared over y. So when we have y squared over y, what we're doing is we're applying the division exponent law. So we're going to go 2 minus 1, which is just y to the 1 or just y. So we put the y down there. Okay, and the last one, 10x squared divided by negative 2x squared. When we divide 10 divided by negative 2, we get negative 5, and the x squareds cancel out, so that one's done. Okay, only like terms can be added or subtracted, okay, together. And as a recall, like terms have identical variables. So they either have to have both x's or both x squareds, okay? And those are like terms. X does not equal x squared. These are not like terms. Okay, so let's go ahead and simplify each expression. So when I'm taking a look at 2x plus 6 minus 4x plus 8, I notice that the 2x and the negative 4x both have x's on them. So you can choose to write them beside each other to make it a little bit easier and a little bit more organized. So let's do it that way. And then we have plus 6 plus 8. And those two numbers are they're just numbers with no variables on them. So those are also like terms. So 2 minus 4, I get negative 2x. And then 6 plus 8 is 14. Okay, for b, 2x squared minus 4x plus 3x squared minus 11x. So immediately I see the x squareds, and I also see the x terms here. So 2x squared plus 3x squared minus 4x minus 11x. Okay, so let's collect these two. We get 5x squared, right? 2 plus 3. And just be careful, we have negative 4x minus 11x. I get negative 15x. Okay, and the next one, x plus 4 plus, and then we have a trinomial here in brackets. Here's the thing, because there's a plus sign in front of the bracket, we can actually just drop the brackets and just add. Okay, so we have x squared minus x plus 5. So we're going to start with the x squared. Then we're going to keep going with the plus x minus x. And then the plus 4 plus 5. Okay, so x squared is the only one with an x squared on it, so we just bring it down. These here actually cancel because we have a plus x and then a minus x. And then we'll have plus 9. Okay, scrolling down, distributive property. So distributive property is when we have a monomial and a binomial. And this monomial gets multiplied by b, giving us ab, and it gets multiplied by c, giving us ac. Okay, so let's go ahead and expand for example 5. 2 times x is 2x. 2 times negative 3 is negative 6. And that's how we expand 2 times x minus 3. Okay, now b. We have a negative 2 as the monomial, and we're going to expand it by multiplying it into every single term in the bracket. So 2x times, negative 2 times x squared, negative 2x squared. Negative 2 times negative 4x, I get positive 8x, right? Negative 2 times negative 4. And negative 2 times 5 is negative 10. Okay, same thing for c. Multiply this 5x into each and every term in the bracket. So 5x times 2x is 10x squared. Remember, x times x, what we're doing is we're adding these exponents. So we get a 2. Okay, and then 5x times 1, we get 5x. Okay, the area of a rectangle is length times width. And don't forget, you always have to state the units, and they're measured in square units. So this could be centimeters squared, this could be millimeters squared, feet squared. Okay, if they don't actually specify the units, we can just put units squared. Okay, calculate the area of each rectangle. We're going to go area equals length times width. So 17 times 2x. These are both monomials, so 17 times 2, we get 34x. Okay, and then we'll call that units squared. Okay, for b, we're going to put 2 times x plus 5. I always tend to put the monomial in front because it's easier to see it when we distribute it into the brackets. So 2 times x is 2x, 2 times 5 is 10. And then this will be measured in units squared. Okay, and example 7, square each term. So let's bracket this and square it. Expanded form would be negative 5 times negative 5, which gives us 25. Okay, b, bracket and square. Expanded form would give us 2x times 2x, which is actually 4x squared. Okay, and then c, bracket and square. So negative 4x times negative 4x, Well, we're going to get 16, right? Negative 4 times negative 4 is 16, and then we're going to get x squared. Okay, example 8, evaluate each expression. So we have 7 squared minus 5 squared. So if we just put 7 squared into our calculators, 7 times 7, we get 49. And then if we put 5 squared into our calculators, we get 25. Okay, so we get 24 as the answer there. Now 8 squared is 64. Okay, bring down this minus sign, and if we do negative 2 squared, we get 4. So our answer is 60. Okay, now number 9, determine the area of the shaded region. So the area of the shaded region is right here. What we're going to need to do is we're going to need to find the area of the big square, I should say. Okay, then we're going to have to find the area of the little square. And then we're going to have to subtract this area out, right? The little square out. So remember, length times width for both like rectangles, and just as a reminder, a square is a rectangle. So we're going to get 10 times 10, which is 100 centimeters squared for the big square. And the little square is going to be 4 times 4, which is 16 centimeters squared. Okay, so the area of the shaded region is 100 minus 16, which you get 84 centimeters squared.